everyone, I'm Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on definitions and terminology on power switching devices. So here we have total the first module 15 definitions and terminology. So first definition is what is power electronics. What is meant by power electronics? Here the definition is the study of controlling the flow of electrical energy with the help of electronic circuits is defined as power electronics. Means power electronics means the study which deals the design, control and conversion of electrical energy from one form to other form. That means AC to DC, DC to AC, DC to DC and AC to AC, fixed to variable. So now that is power electronics. It is a branch of electrical and electronics engineering subject. Now next second question. What do you mean by Thyristor? Thyristor means silicon control rectifier, SCR. So now what is definition? Here Thyristor is a 4-layer semiconductor device. So now 4-layer PN semiconductor, 4 layers. So here 4-layer semiconductor rectifier in which flow of current between two electrodes is triggered by a signal, that is third electrode. So that is it is connected. This is the anode and this one is a cathode and this one is a gate. So normally here we have two current flow between these two electrodes, so anode and cathode, and the third one is gate electrode, gate terminal. So it consists of 3 terminals, anode, cathode and gate. So now 4-layer device and 3-terminal device, and if you connect the supply to this one, supply, and it is diode is in this SCR in forward bias. Here it is a 3 junction, J1, J2 and J3. This is J1, J2 and J3, and J1 and J3 is in forward bias and J2 is in reverse bias. J2 is in reverse bias. So now if you give the positive signal to this gate and cathode terminal, and this J2 is in forward bias, and then current flows between anode to cathode. In this way Thyristor, silicon controlled rectifier, works. So now it is a 3 junction, 3 terminal, 4-layer device. Next, third definition here, latching current. What do you mean by latching current here? So latching current means, see the definition first. Latching current is a minimum anode current. Minimum anode current required to maintain the thyristor is on state immediately after thyristor has been turned on. The gate signal has been removed. Here this is the thyristor, PN, and this is the supply voltage if you are giving positive supply. And now this is the gate terminal. Now here this is anode current. So now here if you draw the graph between this anode current and this voltage, anode voltage VAK, this VAK, and this anode current, So now the graph should be like this one. So now this is the reverse blocking mode. It has it conducts in 3 modes. First one is the forward blocking mode, so this region, and next forward conducting mode, and next reverse blocking mode. Now here if you give some amount of voltage to this one, so this J1 and J2, J3 are in forward bias, and next J2 is in reverse bias. This J2 is in reverse bias. So now here, if you increase this voltage and this J2 junction breaks, and this diode conducts from forward blocking mode to, if you give some amount of this voltage that is in forward blocking mode, and if this reverse bias voltage increases, this voltage increases is greater than this reverse bias voltage, and this diodes comes to the forward conducting mode, that is VBO, forward breakover voltage. And now if you give the voltage also, if you give some gate voltage also, that gate current, so now if you give the gate current also, this breakover voltage decreases and diode comes to the forward conducting mode from the forward blocking mode, and this is IG1, IG2 and IG3. So now here minimum anode current required to maintain, so minimum anode current required to maintain on state, that is forward conducting mode, immediately after thyristor has been turned on. This is the latching current, that is latching current when gate signal has been removed. And next, another definition is also same here. Describe the holding current. So it is related to the turn off process. Here holding current is also minimum anode current beyond the turning off. So now here the holding current is associated to turn off process, and holding current is always less than latching current. Holding current by IL equals to 0.4. So this is the relation between latching current and holding current. So now here this one in this, so this is the latching current and this one is the holding current. Holding current is always less than the latching current. So if anode current less than this holding current, the diode must be turn off. That is turn off method. And next here, next bipolar junction transistor, that means BJT. So that is BJT. It is a solid state device in which current flows between two terminals, collector and emitter, and is controlled by amount of current that flows through the third terminal, that is base. So this is the emitter, base, collector, emitter, collector and base. So now it is a solid state device, and current flows from between two terminals, collector and emitter, and this is controlled by base. So it is a current controlled device. MOSFET is a voltage controlled device. So now here it is a current controlled. So it is controlled by amount of current flows through a third terminal, that is base. And next here, define natural commutation. So commutation means what? Before going to explain this natural commutation, commutation is the turning process of thyristor, that means SCR. SCR is a semi-controlled device. So this is the SCR symbol. So we can turn on by giving supply IG and gate current, gate signal, and VAK is greater than 0 and IG is greater than 0, then we can turn on. Once it is turned on, so once it is comes from forward blocking mode to and forward conducting mode, so it will not turn on. So it is a turn on is in our hand, turn off is not in our hand. So now for that case we need to use some additional technique, that is commutation. Turn off process so is known as a commutation. Here there are two types of commutation techniques here. So first one is a natural commutation and second one is a forced commutation. So here natural commutation means it is thyristor. Any other external device is required to turn off the SCR here. So here turn off thyristor, SCR is turned off naturally without using any external components like inductors, capacitors, any load also, circuit. So it is turned off by supply only. If normally natural commutation is used only for AC circuits. So now here natural commutation is observed in the AC voltage controlled AC to AC and phase control devices AC to DC and cycloconverters AC to AC. Normally when it is input is AC, in that case only we can observe that natural commutation circuit. But coming to the forced commutation, so for the DC circuits, so there is a requirement of external components to turn off the SCR. So now here define the forced commutation. So now here the process of turning off SCR or Thyristor by external circuit, external components, that means L and C, inductor and capacitor, is known as a forced commutation. This commutation we can observe in the DC circuits. So that means DC to DC circuits, and that means choppers, and DC to AC circuits, that means DC to AC circuit, that means inverters. So now the circuit is used for commutation method is known as the commutation circuit, and the components that are used in the circuitry is known as a commutating components. Here L and C are the commutating components. Next here describe the snubber circuit. So now this is the SCR. So there are different components to protect the SCR from the dV by dt protection and di by dt protection, and there may be over voltage protection, over current protection. So for that case, now here over voltage protection we will use some components, and over current fuses we will use. And next there is a for dV by dt protection we will use one circuit, that is snubber circuit. So now snubber circuit means R and C. Here snubber circuit is the combination of resistor and RC circuit. R, this is the R and C. This is connected across the switch. So Thyristor acts as a switch. If you connect this one, and this is this one. So if you connect this snubber circuit across this Thyristor, so it will protect from the dV by dt. So for improving the performance, so snubber circuit is mainly used for to protect the SCR from the dV by dt. Next, rise time of the SCR. Now if you there are different characteristics, IV characteristics and switching characteristics and dynamic characteristics. So now here in the switching characteristics, so Thyristor characteristics are IV, voltage current characteristics, switching characteristics and dynamic characteristics. In the switching characteristics, so here the rise time from the switching characteristics only we can define the Thyristor rise time definition. So first here the rise time of Thyristor is taken from the anode current. So this is, if suppose this is anode current from 10%. For this is the this is anode current. This is the this is the zero anode current, and now here this is leakage current. So some leakage current from the 10% of anode current to the 10% of anode current to the 90% of anode current. So this time is known as the rise time of its final value. This is the final value. This is 100% and this is the 90%. So this time period is known as the rise time. In another way we can define, so this is, suppose this voltage is initially it is 100%, from the 90% to here this is the VAK, and this one is from the 90% to the 10% is known as a, its initial value is known as a rise time. Two ways we can define. So from the anode voltage from the 90% to the 10%, and anode current from 10% to the 90% of its final value and of its initial value for anode voltage. So this time period, this time duration is known as the rise time. Now here 10th one, define load commutation. So this is one another type of commutation to turn off the SCR. So to turn off the SCR, SCR turn off method, here by load only, external voltage. Here there may be induced voltage in the load. So because of that induced voltages in the load, thyristor will be turned off. So such type of turning method is known as a load commutation. So now here define a derating factor. So now here derating factor means here, so derating first. So what do you mean by derating? Derating is the operation of a device at less than its rated maximum capability in order to prolong its life. So now here sometimes we will use thyristors are connected in the series. So now this is series connection. Sometimes we will connect in the parallel connection. So thyristors. So now for that case, this term comes here. So first derating factor is amount of, this is one string. So string efficiency we will calculate some. So now that this string efficiency is this one. So this string efficiency, so here derating factor is an amount which the string efficiency deviates from the unity or 100%. If suppose string this is string efficiency and this is derating factor. So now here derating factor equals to 1 minus string efficiency, or 100 minus 0 if it is in percentage, and 100 minus this one percentage. And derating factor gives an idea of unused capacity of available in the string of SCRs. So unused capacity of capacity available in the string. And next it measures the reliability of the string. Next, what is the relation between gate signal and forward breakover voltage? So already I have drawn the forward breakover voltage. So this is VAK and this one is the IA anode current, and this is the, let me change the color over here. This is the anode current characteristics, and this is in reverse bias. Now here this one in this. So now this is the forward breakover voltage VBO and gate signal. So now this is the gate signal. So now here this is the thyristor PN, and this is the VAK V supply voltage and anode voltage and cathode, and this is the gate supply IG. So this is the gate. So now here what will happen if you give the positive terminal is connected to the anode and negative terminal is connected to the cathode. And next here, so now the J1 and J3 are in forward bias condition. J1 and J2 are in forward bias condition, and J3 is in reverse bias condition. So now here, so now up to here forward blocking mode, and when if you give when this supply voltage increases this breakover voltage, and that for SCR comes into the forward conduction mode. So that is breakover voltage. That voltage, that point is known as a breakover voltage. Now if you give some amount of extra voltage to this gate pulse, so now here there is a gate current. If you increase this gate current, and this breakover voltage will decreases. Gate current lowers the breakover voltage, and this one and this one. So IG1, IG2 and IG3. This is reverse blocking mode and reverse breakover voltage and reverse leakage current. This is forward leakage current. Now here thyristor can be triggered by increasing forward voltage between anode and cathode, this one, and next at a forward breakover voltage starts conducting. So from forward breakover voltage to the forward conduct. However, this process may damage the thyristor, so this is not suitable. So to turn off the SCR, there are different methods. So increasing the forward breakover voltage, that is not uh, suitable, safe for thyristor, so that may damage to this. So the gate the current gate signal is given to this one, that is best method. So thyristor is advises to trigger on through the gate pulse. So this method is better. So in this way also, if anode voltage is greater than VBO, then we can turn on the thyristor. So thyristor comes from forward blocking mode to the forward conducting mode. But here, if you give, that is not safe. But here, if you give the gate current, so that is okay, advisable method. So now here, if you give the gate current, so that forward breakover voltage decreases when gate signal is applied and turn on before reaching the breakover voltage, and from forward voltage at which thyristor triggers on depending upon the, so this value is depending upon the magnitude of breakover voltage. So if you increase this gate current, and this breakover voltage decreases. And next here, describe the firing angle. Firing angle means firing angle refers to, so now here this is a thyristor. So thyristor, this is if you give some amount of supply here, if you give some amount of supply, refers to the phase angle of the AC supply, and when gate current is applied, and it will turn on. So there may be a time delay. And now here the lower the firing angle, higher power is transferred to the load. So now there is a firing angle. So now here it will not turn on immediately. There is a firing angle. Firing angle refers to the angle of AC supply when gate current is applied. So initially it will not turn on. So anode PN, and if you apply, if positive terminal is connected to the anode and negative terminal is connected to the cathode, it will not turn on. J2 and J3 is in forward bias, but J1 and J3 is in forward bias, and J2 is in reverse bias. So when you give the gate pulse only, it will turn off. So when you give that, it will turn on. So such delay time, such time is known as a firing angle. So now here, next 13th one, define extinction angle. So extinction angle is a one where thyristor gets turn off in spite of being reverse biased. So up to what angle is in reverse bias, and SCR is feeding to inductive load, then the current lags voltage when voltage becomes VE, but load current does not fall to zero, and the thyristor keep on conducting. The angle when current falls to zero and thyristor gets switched off is known as this definition. The angle where current falls to zero and thyristor gets switched off to the off is known as the extinction angle. Next, last definition in this. So what is the difference? What are the different losses occur in the thyristor while operating? So these are 4 operating losses. So first one is a forward conduction losses, and next, loss due to the leakage current. There may be a leakage current. This is leakage current. And forward conduction, this is forward conduction mode. In the forward conduction mode, the current flows in the thyristor. So because of that current, anode current, there may be forward conduction during the conduction of thyristor, and due to the leakage current in due to the loss due to this leakage current, and I square R, and power loss at gate or gate triggering loss. If you are giving the gate pulse, means there is a current, that due to that current means the gate current. So power loss due to the gate, and switching losses at turn on and turn off. So while turning off and while turning on, so there may be a loss. That loss is known as a switching loss. Here, forward conduction loss, leakage loss due to the leakage current. And next, There may be a reverse leakage or reverse leakage current also due to this one also, forward and reverse. And next, power loss due to the gate and switching losses. I hope all these 15 definitions are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.